Thank you, everyone. Good morning. I'm going to try to read the presentation view for the first time because I refuse to get bifocals. So we'll see how this goes. I'm really excited to be presenting this paper to you today on the conservation treatment of Apollo 11 Columbia. When the National Air and Space Museum announced that they were going to send Columbia on a 2-year tour, it gave our conservation unit a rare opportunity to relook at this iconic object. No one needs a review, but on July 16, 1969, Apollo 11 Columbia was launched into space by a Saturn V rocket towering over 375 feet high. After separation from the first 3 stages, the command module and service module served as the mothership to astronauts Buzz Aldrin, Neil Armstrong, and Michael Collins as they orbited. After this historic 8-day journey and the mission, the command module was the only part of Apollo 11 that returned to Earth. It splashed down in the Pacific Ocean, carrying with it its 3-man crew, the equipment, and lunar samples from the moon. A Kapton covering, this polyimide tape that you see on the exterior of Columbia, was scorched from re-entry. This was the first time humans had landed on the moon, so as you can imagine, the fear that was instilled in people worrying that the astronauts had brought back biological pathogens to Earth was real. So NASA quarantined the astronauts for over 2 weeks, twice the time of the actual mission. And they decontaminated and cleaned every part of Columbia. When NASA was satisfied that the spacecraft was safe to handle, they embarked on a 50-state tour, and Columbia traveled the United States in a purpose-built trailer that doubled as an exhibition space, and dignitaries and the public were allowed close-up personal views of these national treasures. Sorry, I'm just looking for the mouse that got lost, Jessica. As the command module, sorry, I don't see them.
It up on the screen.
Okay. Skip that part. After the tour, NASA transferred Columbia back to the Smithsonian for preservation and display. It was first displayed at the Smithsonian Arts and Industry Building, which you can see here on your left. And then NASA opened its doors into the public in 1976. If you've ever visited the National Mall Museum, for the last 40 years, you'll recognize this photo on the right of Columbia displayed in its tight-fitting plexiglass vitrine until 2014 when we disassembled milestones of flight. Yeah, I'm going to need the mouse. Can you help me? Sorry. Because I can't get my...
It seems to have...
Oh, there you are.
There we go. If it goes all the way over, it ends up on the screen because it's extended.
Okay.
There you go.
Sorry about this. Okay, perfect. We're in business now. In honor of the 40th anniversary of the museum, the Milestones of Flight Gallery underwent a major renovation, and at that time, Columbia was removed. It was scheduled to be relocated and become the centerpiece of our new Apollo Gallery that Rachel talked about yesterday, Destination Moon, which was originally scheduled to open in 2021, but it had just opened in October 2022. So the question of where to put Columbia in the meantime became a hot topic at many gallery meetings. And after much discussion, NASA made the decision to send Columbia out on its 2nd national tour. In partnership with the Smithsonian's Institution Exhibition Traveling Service, or SITES, we began to prepare for a 2-year tour that included Columbia and 20 flown Apollo 11 objects, many of which had never left our museum before. This includes this amazing Saturn V fuel injector plate, which Paul talked about yesterday, and Rachel also talked for the Destination Moon Gallery, that came on tour with us after it was conserved by Terramar Conservation. Medical kit with its original contents from flight, and a wonderful rock box collection that was vacuum sealed on the moon and carried samples back to Earth. The first step towards this effort was to actually attach a transport ring to the base of Columbia to eliminate handling on the tour and provide as a display stand while it was on exhibit. Using the 3 original bolt holes on the base that attached the command module to Saturn V during launch, an original Apollo-era transport stand was refurbished by our museum and fit with NASA-specified casters to secure the spacecraft to. Forklift pockets were also added so we could ease with movement in and out of its transport container. One of the challenges of displaying Columbia are the visitors' desire to be up close and personal with this object, and they can't really see inside it very well. So the curator used this opportunity to undertake a 3D scanning project and produce an interactive online tour so that visitors could explore every nook and cranny of the Columbia, inside and out, and engage with the object in ways that would never have been possible before. During the 3D scanning project, handwritten notes were revealed on the interior walls and lockers, including markings that can be associated with each point in the Apollo 11 mission. Most of these were written by Command Module pilot Michael Collins in communication with Mission Control. For example, one set of markings shown above on the left indicates a series of numbers related to a very important maneuver that took place 75 hours into the mission. After that time, the service module propulsion system was used to change the spacecraft's flight in order to orbit around the moon. On the right, a small hand-drawn calendar shows the mission days crossed off one by one during the flight, and the last date of splashdown, July 24th, was left unmarked. In an effort to preserve the calendar in flight, a piece of plastic was cut and secured using tape, so the corner could be easily opened and closed each day by Michael Collins. This calendar represents a unique perspective into how the astronauts responded to living and working in Columbia, and as Michael Collins anxiously awaited the return of astronauts Neil Armstrong and Buzz Aldrin from the lunar surface. In order to fully treat and prepare Columbia for the tour, it first had to be moved from the museum in Washington, D.C. to our conservation laboratory in Virginia. Its size and unique shape prevented it from being transported inside a closed trailer, so we developed a plan to wrap it using a 3-layered system. First, we covered it in Tyvek and then used a polyester batting to protect it, and ended up using a shrink wrap material so it could be protected on the back of the trailer. It took a team of 8 of us 5 days to wrap Columbia. Our NASM collections team, complete with CDL drivers, trained riggers, all planned the transport of Columbia after museum hours and coordinated the entire effort from road permits to police escorts to transportation and offloading all in one night. Finally, the conservation team was ready to develop their treatment methodology to preserve and stabilize Columbia for our tour. Columbia was positioned in the restoration shop, front and center, so the public could see the conservation effort and it could remain on public display throughout the process. The conservation team spent almost 500 hours one summer to complete the treatment. The team consisted of 2 conservators, myself and my colleague Malcolm Cullum, and the majority of work was completed by 3 very enthusiastic conservation fellows who worked diligently to document and clean the command module. They were also instrumental in tracking all of the photos, resources. We've been talking a lot about archives. We generated condition maps, archival documents, all of our technical documents, and the documentation for the process. Whenever I tasked them with hard questions, they didn't tell me once that summer that they never covered space material in graduate school, and they applied what they learned in conservation training to this complex project. You can see in this picture an interesting aspect to our work is reuse of materials, and this yellow platform was one that we received with Discovery from NASA, was used to get into shuttle, and we repurposed it for our uses in our work in the shop. The NASM collections and restoration staff also worked endlessly to support our project. They provided rigging movement, the building work platforms, locating technical reports, and coordinating the outgoing transport with our security teams and rigging specialists for each of the sites. Due to the size of the project, we approached the conservation treatment in 4 stages. We tackled the interior last because it would be the most complicated and needed the least amount of work. The central heat shield, which covers approximately 60% of the exterior surface, the ablated heat shield on the base, and then the upper section which housed the control system, engines, and communication gear and parachutes. We also addressed miscellaneous features located on the spacecraft that required individual treatment plans based on their material, function, and condition. Some of these unique features you can see here. For instance, these very two distinctive circular knobs on Columbia raised interest with our team and frankly anyone who asked us about the spacecraft. Historical documents identify them as waste and water vents, but what is interesting are the materials chosen so this seemingly easy task in flight could be accomplished in space. A small hole in the center of the vent allows the astronauts to manually empty their waistlines into space, if anyone remembers the movie Apollo 13. What wasn't recorded in the technical reports was the material chosen to cover it in pure gold. A small heater unit inside helped to keep the lines from freezing, and the gold coating prevented the liquid from freezing on contact, ensuring that the vent stayed unblocked during use, which could have caused potential problems during flight. Almost 70% of Columbia is covered in a signature orange-colored heat shield, which was designed to form a protective shell around the spacecraft and withstand extremely high temperatures of up to 5,000 degrees Fahrenheit during re-entry. By studying a manufacturing sample of the heat shield, our team was better able to interpret how the different layers were formed and began to understand what we saw left on Columbia or not, and on the degraded outer layers of the heat shields. On a stainless steel honeycomb shell, a thin layer of epoxy tape adhesive, number 1, was applied to a clean metal surface. Then number 2, the fiberglass honeycomb was attached to the surface in large sheets formed to fit the curved shape. At number 3, at this stage, the entire spacecraft was bagged and cured. Then the honeycomb walls were primed to increase mechanical strength during number 4 with an aluminum-filled epoxy phenolic resin that was applied by spray. Over 350,000 voids were hand-filled using AvCoat, a name given by NASA to the ablative epoxy phenolic resin used on heat shield materials and manufactured by Avco. It was allowed to cure in an oven for 250 degrees overnight, and then surfaces were machined and designed to the desired thicknesses. Next, the technicians radiographed every inch to be sure there were no pockets or mistakes in the heat shield and allowed only 3 repair cycles over the next 24-day period. This is what was referred to as the green state. Stages 6 through 8 included the application of a clear and white pore sealer and a final coat of titanium white thermal layer. The white outer surfaces were then covered with the patterns of gold and silver Kapton tape to ensure that it was protected further from radiation. So what does this look like on Columbia once it's been to space and back? 50 years later, the adhesive residue patterns are still visible where the surfaces where the Kapton tape was removed when it was returned to Houston. The team mapped the surfaces so that we could determine where to clean and to be sure not to disturb or remove any evidence of use in this process. The challenge of cleaning such a seemingly robust object was time-consuming due to the very fragile surfaces. The team had to use small tools and move methodically in order not to disturb friable materials or remove too much dirt too quickly. The team used traditional dry surface cleaning methods like a soft brush and vacuum and tested a variety of methods, but in the end a soot sponge worked best to thoroughly clean the surfaces. One of the biggest unknowns of traveling Columbia was the condition and stability of the aft heat shield. This is composed of the same material as the central heat shield, but it was applied much thicker to form the ablative surface, which means that the material would melt and burn off during re-entry, creating a plasma that carried the heat away from the spacecraft and the astronauts. As a result, the heat shield remains charred, physically damaged, and friable. You can still see the center point of where the heat interacted with the base and radiated out across the surfaces. Condition damages noted including compression markings and surfaces from the original transport stand, iron staining, bolt holes where it's attached to the bottom of the inner conical spacecraft, and other markings are here marked on this diagram. There's also a white, thick ablative material redeposited across the surfaces, which can be seen throughout. In order to determine a treatment method to stabilize the heat shield, we wanted to know 2 questions. Basically, we wanted to know whether or not the porous material was still contaminated with chlorides from splashdown, and whether or not the physical structure was strong enough to survive the tour. Other markings found on the heat shield include circular, rectangular, and oval shapes drilled out of the material. This represented pre-flight repairs where air bubbles and anomalies were found during the manufacturing process. Some of the circular fills are further sealed with an aluminum epoxy fill on the exterior edges, which help to dissipate the heat. Analysis of the central and aft heat shields was undertaken using portable FTIR. Results confirmed that both heat shields are composed of the same material, with peaks for bisphenol A epoxy and fiberglass, which was most likely the walls of the honeycomb material, silicates and silicone polymers, which could be part of the coating system that's left behind. Further analysis using both portable XRF and FTIR confirmed that the white waxy powder seen across many of the surfaces was feared that we could have sodium chlorides, but turned out to be a calcium stearate related to the redeposition of the ablated material from the heat shield upon re-entry. Powdering of this material is most likely due to humidity and temperature fluctuations in the gallery over the past 40 years, as well as aging of the materials themselves. Damage related to flight is also seen on the side of re-entry shown here, where it's missing material and is related to Columbia hitting the ocean water during splashdown. The spacecraft was designed to absorb impact on this side and was engineered with collapsible titanium ribs right underneath the heat shield to buffer this effect. The force that Columbia experienced when it hit the water accounts for most of this damage. But as mentioned before, some of the missing materials on the heat shield edges can be attributed to visitors when it was on its first national tour, and people were allowed to get up close and personal with the artifacts. Some other interesting material choices made by NASA, keeping in mind that everything used on Columbia had to survive both the harsh environment of space and re-entry without failure, include high temperature glass used for all the windows and the hatches. A borosilicate glass was used for the S-band antenna cover, which is here up on the upper left. This is what it looks like when it was found burned on one side. The umbilical, which provided communication and power to the service module, which is composed of copper alloy sheathing and was jettisoned off when the service module separated. So that's on the bottom left here. And the equipment bay doors found around Columbia. There's over 18 panels that are made of the same heat shield material, but they're attached using a bolt system, and then inside each bolt hole is a cellulose material mixed with plastic micro balloons to protect the bolts during flight. We also undertook treatment of the top section of the spacecraft, originally used to house the parachutes, rocket nozzles, and communication antennae. Most of the treatment involved light corrosion, removal from aluminum alloys and iron hardware, surface cleaning the plastics and textiles, and some of the coated materials. Our initial inspections and high-resolution photographs during the 3D scanning process meant that we only had a few tasks to really perform inside and wanted to stay inside very minimally. Historical records showed that Columbia tipped when it was recovered in the ocean, and water got into the spacecraft. So we naturally wanted to be sure that this had not caused salts to precipitate out and corrosion to form on metal hardware. Minimal cleaning and decontamination took place after recovery, as I mentioned, and in personal communication with the technician who performed this procedure, he was instructed not to wipe down the wall surfaces specifically, and he was told to use a vapor form of paraformaldehyde to disinfect the air and interior surfaces, which he literally sat a hot boiling material in a frying pan on the seat in Columbia and let that vaporize for over 24 hours. I think it's sort of like modern day Lysol. That's what it would be similar to. For the most part, the materials chosen inside were inert and interior components remained stable. Minor corrosion was located on some of the stainless steel hardware. Other condition issues expected and noted for future monitoring were discoloration and degradation of the plastics, the beginning of adhesive and coating failures, and the evidence of wear to mechanical lockers, seats, and other equipment. In addition to treatment issues, the curator asked us to look for items in Columbia that had been donated to the museum but never found. We located these 3 camera lenses, which are in the top center picture, found intact in the locker where they originally showed during flight. You can see Michael Collins in the picture below in a training simulator operating the camera lenses in that same locker. We decided to leave the materials inside Columbia because we felt it would be safer for them in the future. A lot of the materials have been removed, but because these were tethered in, we decided that they should stay inside the spacecraft. A small amount of paint loss was also observed in the interior surfaces on the walls. Despite our literature search, the use of paints and coatings in Columbia were not well documented. We do know that many of these materials changed after the Apollo 1 fire to include fire retardant additives. So we were curious to see if they altered the coating systems as well. And that was causing some release of the paints now. A small paint chip was recovered from the interior that had fallen onto the floor, and the curator allowed us to use this for analysis. Initial analysis using the Agilent portable FTIR identified the paint as an alkoid paint system with silicon dioxide microcrystalline filler and evidence of titanium white. XRF also confirmed the presence of these same materials. However, we had no information on the green color or pigmentation of the paints seen in our images or on the paint chip. We then decided to take our samples to the National Museum of Natural History at the Smithsonian, who offered to use SEM and EDS to further characterize the paint sample. As seen by this black and white image on the right, a large amount of glass microballoons are present in both round and rod shapes. And titanium is also visible across many of the surface, shown by the dense white splatter. And then tiny fragments of silicon, similar to quartz, was identified as possibly accounting for the pigmentation of green or blue color. The effort to use so much silica and microspheres could be directly related to the rating of the paint requirements. SEM cross-sectional analysis resulting in a composite X-ray map is shown here at the bottom in gray. The primary elemental maps for silicon, which is shown in green, and titanium shown in red, show evidence of the missing silicon dioxide possibly used as filler to pigment and the paint. We are still looking into the final research onto this coating system, and if anyone has information, I'd love to hear about it, and answering questions about how the spacecraft walls were prepared to receive the paint system. There's a silicon binder on the reverse side of the paint chips, which is releasing the paint from the walls. We are hoping to, we did not do any treatment on this. We're hoping we mitigated it by using preventive methods and improving our display environment to help keep the paint more stable. So it's not flaking actively if you come into our museum, but 50 years from now, we may have to be dealing with some of this. After treatment, the command module was ready to move again. A protective cover was designed for use during the tour so it could be safely moved in and out of venues, and none of the surfaces were exposed while it was transferred in and out of its transport container on the road. The container was designed to keep a low relative humidity at 35% on the road and a stable temperature, which we monitored remotely. The container was positioned on the back of a double-wide trailer and escorted to 5 venues across the United States. FedEx did all of our shipping as an in-kind. I can say this now because the show's over. As an in-kind donation to the museum. And Jeff, who's here from the museum, a flight in Seattle where it was hosted in 2019 can give you an up-close and personal opinion about how that show went. Seattle was our furthest venue that we took the command module to. As you can see here, it traveled from 2017, stopping at 5 venues. It was supposed to stop at 4. We extended the show after Seattle to 1 more venue, and thankfully it was received back at NASA in February 2020, exactly 2 weeks before the world shut down, and we had Columbia safely at home. Or Lisa would have been not here today, probably from an anxiety attack. The first stop was Space Center Houston in 2017, and this is a picture of it showcased in their central gallery. It also went to the St. Louis Science Center, Heinz History Center in Pittsburgh, Seattle Museum of Flight for the 50th anniversary, and the Cincinnati Museum Center. Each show was 4 months long, and we spanned a month on each side for NASA staff to escort, install the show, condition report the objects at each venue, provide any on-site cleaning to Columbia, prepare the show with the venue, and then on the back end do the same thing, deinstall Columbia and the artifacts, send them on the road to be received at the next museum. So we did this for 3 years, 2.5 years, traveling with it. And it was an amazing experience. Everything went really well. So that's it. I want to thank everyone who helped with this project. As so many people have alluded to today, it takes a team. It is not just me working on Columbia. I want to dedicate this talk to my colleague Rob Merwini, who is no longer with us, but was very instrumental on the show. And then the Apollo 11 astronauts, Neil Armstrong, Mike Collins, and Buzz Aldrin, who brought their ship safely back to Earth. Thank you.